In this video, I'm going to take a quick look at multiplying whole numbers by fractions. Now I have to remember that when I'm multiplying whole numbers, let's say 3 multiplied by 6, and what I'm really saying is that it's actually 3 sets of 6. So it's 6 plus 6 plus 6. The only reason we multiply is because it's much more efficient when we're working with larger numbers than doing a long string of addition. So what I end up with is 3 multiplied by 6 equals 18. And 6 plus 6 plus 6 equals 18. So I just need to remember that when I look at my multiplication equation, I've got 3 sets of 6, and here they are, 1, 2, 3 sets of 6, and they both equal 18. When I'm working with fractions, I'm doing the exact same sort of math. So for example, if I'm going to multiply 4 multiplied by 5/6, then what I'm saying is that I've got 4 sets of 5/6. So I'm going to look at it right here. 5/6 plus 5/6 plus 5/6 plus 5/6. Now hopefully I can recall that when I'm adding fractions, if I have the same denominator, and in this case I do, I don't need to change anything about my fractions at all. I just simply need to add the numerators together. So literally I'm adding 5 plus 5 plus 5 plus 5, and that's going to equal 20. And they are all parts of 6, so that does not change. It's 26. Now the last thing I have to keep in mind is that if I have a number like 26, I can actually change that into a mixed number. Right now it's an improper fraction because the numerator is larger than the denominator, meaning that there is more than one set of 6 in here, meaning there's more than one whole number involved. So I can do some multiplication equation, and I'll work through that in a second, but if I'm struggling with this idea, then what I should really do is I should start drawing sets of 6. 1, 2, 3, 4, 5, 6. That's 6 things. Another one, 1, 2, 3, 4, 5, 6. That's 12. Another one, 1, 2, 3, 4, 5, 6. That's 18. And I need to get to 20 pieces. I've got as far as 18, but I need to get to 20, so I'm going to be able to only add 2 more pieces here. So if we take a look at this, this is one whole set of 6. This is one whole set of 6, and this is one whole set of 6. This means that I've got 3 whole sets of 6, which means I've got 3 whole numbers. Now how much is left over? Well, let's take a look on the next page. So I already said that I have 3 whole numbers, and then I had just 2 6 left over, just 2 that got me to 20. So the way that I write this number is a 3 as a whole number, and then 2 6ths, because that's what I had left over. This is a mixed number because I've got a whole number, and I've got the fraction remainder, the part that's left over. Once I'm comfortable with that idea, there is a faster way to go. So I can take my original 26ths, and I can basically say 6 divided into 20, or 20 divided by 6, which is what I'm doing here, right, equals 3, and 2 remainder, 2 6ths remainder. Okay, so I'm doing the literal division equation. I know that 6 goes into 20 3 times, and there are 2 left over. So 6 goes into 20 3 times, 2 left over, and those would be 2 6ths. So let's do one more quickly here just to test and make sure we know what we're doing. I'm going to do 5 multiplied by 3 halves. Okay, so what I'm going to look at here is, again, that's 5 sets of 3 halves. So either I'm drawing out the 3 halves plus 3 halves plus 3 halves plus 3 halves plus 3 halves. Or, hopefully if I can start to do it mentally, I can recognize that 3 plus 3 plus 3 plus 3 plus 3 equals 15, just like 5 multiplied by 3 equals 15. So that's going to equal 15 halves. And let's check with the addition. 3, 6, 9, 12, 15. Yep, that equals 15 halves. Now to go from 15 halves, which is clearly an improper fraction, I need to take a look at how many times 2 divides into 15. So I look at this just like if I was taking a mark on a test. I was trying to find a percentage. I can divide 15 by 2. 2 goes into 15 7 times, and 7 times 2 equals 14. So that means if 7 times 2 equals 14, then I just have 1 left over to get to 15. So that's 7 and 1/2 remaining.